Good morning, everyone. This is Priya Shakti doing my Masters in Energy System Engineering at Memorial University. Today's topic is energy analysis of heat pump system. Before moving into the topic, let me give you an overview about this topic. So, here we are performing an Exergy analysis on the heat pump system, which is Hitachi, which we have selected for this particular study, and the location selected is Uttarakhand in India. We have calculated the Exergy restriction and someone with the governing equation given, and we have discussed the results here. Let's see more detail in upcoming slides. Thank you. Introduction. Let's see what is Exergy and why we are performing this analysis on heat pump. Exergy is a measure of quality of energy that can be used to do work. Exergy analysis allows us to access the efficiency of energy conversion system such as heat pump system. This goes beyond the traditional energy analysis by accounting this energy of quality and reversibility. The exergy efficiency of the heat pump system is the ratio of exergy output to the exergy input, which indicates how much of the availability energy is converted to useful work. At last, exergy efficiency can be improved by reducing exergy destruction. Now we will see about the selected location and why we have selected this location. Navara is located in northern part of India in the state of Uttarakhand. So the climate of Navara is classified as a humid subtropical climate, which hot in summer and cool in winter. One of the main reasons for choosing Navara is we can analyze both extreme climate situation in one particular city. The average temperature in Navara range from high of 30 degrees in summer and low of 70 degrees in winter. Sometimes it will be like 22 to 30 to 25 in summer and 7 to minus 11 in winter. The hottest month in Davara is usually May and the coolest month is January. The relative humidity in Davara is generally high, ranging from 50 to 80% throughout the year. So in the figure here we can see the temperature profile for each month. This data has been collected from Homo software and the data related to temperature has been collected from Homo software for this particular city. So for performing this analysis, we have gone through many literatures. So here is learning from the literature review, the most important points we just learned from the literature review. Let's see about it. The efficiency of heat pump system is examined using the second law of thermodynamics and the concept is irreversibility. The exergy analysis can be provided using insight into the performance of heat pump and refrigerator and can be used to optimize their design and operation. Solar assisted heat pump systems have been studied for their energy efficiency and COP, and methods have been proposed to calculate the ideal refrigerator temperature. Manufacturers have so far succeeded by only considering the first law of thermodynamics, engineering expertise, and the knowledge and ignoring the effects of the second law. The energy concept has been applied in few academic examples, and these are no studies on the commercial heat pump system currently in use. Now let's see about our heat pumps and its description. So the heat pump which we have selected for this study is Hitachi RSNG318HDXA. It's a split type air conditioning system. The cooling capacity of the system is 3.2 kilowatt and the heating capacity is 3.6 kilowatt. It is R410A refrigerant and has a energy efficiency ratio of 3.64. The coefficient of performance (COP) of this is 3.98. It features a compact design, no noise operation, and the range of advanced features such as automatic airflow adjustment, air purification, and remote control via mobile app. This system is designed for residential and small commercial places. And the system can be used in both small places like commercial and residence. We have this particular pump for the study. Problem description: to present the kinetic COP formula for the heating and cooling system based on second law of thermodynamics. Approach. So we are going to approach this by applying the drives COP analysis concept to the commercial heat pump and air conditioning system, which is Hitachi, using the governing equation in MATLAB to study the variation of energy efficiency and Exergy coefficient of the performance for heating and cooling modes for varying heating and cooling loads. The heating and cooling loads are provided based on the Homer software data. So, so data is being collected from the Homer software, and with the MATLAB we are performing the analysis, and results are being taken from the MATLAB, and we are discussing here.
Hi, this is Shivaram. I'm going to explain about the problem formulation of Exergy analysis of the heat pump systems. And as you can see, these are the cycle and schematic diagram we have been used for the analysis of heat pump system. And I'm going to explain about the terms we have used. W is the work supplied between state 1 and 2. That's where the compressor is. And QH is the heat flow rate from the condenser. QLC is the heat flow to the evaporator. TH and TL are reservoir higher and lower temperatures. TLC is the average evaporator temperature. THC is the average condenser temperature. And we have the finite temperature differences between THC minus TH at the condenser and TL minus TLC at the evaporator. And we have also used a term called QI, that is the internal heat leak from hot to cold end at the system. These are the governing equations we have used for the analysis of heat pump systems. Hitachi RSN model is selected for our analysis, and it's a hot and cold air conditioner, so it can be used for both the hot and cold climatic conditions. The steady state operation input data for the Hitachi air conditioner is chosen from the Hitachi air conditioner technical data sheet, and during the heating mode the air temperature was set at 28 degrees Celsius and 10 degrees Celsius at the condenser and evaporator sets respectively, and for the cooling mode the temperatures are set at 40 degrees Celsius and 30 degrees Celsius. These temperature data are based on the Homer software and for the chosen location. The thermodynamic information for the refrigerant R410A was used from the refrigerant and refrigerant mixture database. Based on the governing equations and standard input data like TH and TL that was used from Homer software, a code was created in a MATLAB to solve the equations. We have simulated this coding for various heating and cooling loads to find out the variation of Exergy efficiency with the various heating and cooling loads for the selected heat pump system. For the results, these graphs are generated based on the code we have created in the MATLAB software, and these graphs are generated based on the formula we have used in the MATLAB software. The left side graph shows the coefficient of performance for the cooling mode, and the right side graph shows the coefficient of performance for the heating mode. As you can see, the coefficient of performance decreases with the increasing load. The coefficient of performance for the cooling mode decreases with the increase in cooling load, and the coefficient of performance for the heating mode decreases with the increase in heating load. Moving to the next part of the results, we have created a graph for the COP versus the thermodynamic temperature ratio. As you can see, the blue line indicates the COP of the overall system, which also decreases with the increase in thermodynamic temperature ratio. We have also calculated the heating mode and cooling mode optimum COP based on the formulas. Next, the important part of the analysis is the Exergy efficiency. We have calculated the Exergy efficiency for various heating and cooling loads. So as you can see the result, the Exergy efficiency also decreases with the increase in cooling and heating load. The blue color line indicates the Exergy efficiency for the heating mode, and the red color line indicates the Exergy efficiency for the cooling mode. We have plotted a graph showing the Exergy COP variation with the increase in thermodynamic temperature ratio. For the heating mode, the Exergy COP decreases, and for the cooling mode, the Exergy COP increases with the increase in thermodynamic temperature ratio. The Exergy analysis of a heat pump system was performed, and the chosen model was a Hitachi RSN model. And from this project, we have known that Exergy efficiency is a decreasing function of load for a heat pump system, and also the Exergy coefficient of performance varies as a decreasing function of thermodynamic temperature ratio for heating mode and an increasing function for a cooling mode. We have also calculated the optimum COP. So based on that, the COP for the system can be improved by 20 to 30%. Thank you.